Hello, third grade, and welcome to Lesson 3, titled Humans and Natural Hazards. This is going to be the last lesson in this module. After that, you're going to have your quiz and your module test. So let's go ahead and get started. So the first pages we're going to complete, you're going to read through. It says natural hazards impact how humans and other organisms live. Put an X on any of the boxes that best describe natural hazards. So you're going to put an X or a check mark in any of these boxes and explain your thinking. Describe your ideas about natural hazards. Once you've completed that section, we're going to jump in and watch a video of a storm surge. We're going to observe the wind and the rain in the storm surge, and then write down at least 3 questions that you have. If you have more than 3 questions, please feel free to write those down as well. Okay, now that you had an opportunity to watch that video, go ahead and write down 3 questions that you have about the storm surge. And then we're going to read about the civil engineer. Once you've read through these 2 paragraphs, I want you to go ahead and answer the questions on the next page. What do civil engineers do? What process does the engineer follow to design bridges? So please make sure you're using complete sentences. Check your spelling and grammar and punctuation. Please make sure you're writing with neat handwriting. If it is messy, I'm not going to be able to read it or grade it for you. Then answer the essential question, how can humans reduce the impact of natural hazards? Give it your best guess. We're going to learn more about these things as we go through the lesson. All right, next we're going to jump into an inquiry activity. For this activity, you're going to use sugar cubes and a book, and you're going to model building. Can a model building withstand an earthquake? So you're going to write your prediction. How many sugar cubes can be stacked without falling over when they are tapped? You're going to follow these instructions to carry out the investigation, and you're going to list during your 4 different trials a number of cubes that were used and your observations. Please write kind of small here so you can write down as much detail as you can. Then you're going to answer the related questions on the next page. After you're done with the inquiry activity, you've answered all of your questions using complete sentences, using evidence from your experiment, using the data that you collected while you were doing it, then we can go on to our next pages. Now here we're going to go over our new vocabulary words. We have the word levee, flood wall, and lightning rod. Let's go ahead and take a look at the definition of these new vocabulary words. A levee is an earth wall that's made to prevent flooding. A flood wall is a wall that's built to reduce or prevent flooding in an area. So a flood wall is man-made, a levee is natural, it's found in nature. A lightning rod is a metal rod, so it's a long metal stick, basically, that's designed to make a path for lightning away from buildings and into the ground. So in the middle of a lightning storm, a lightning rod would be this really, really tall metal pole that would be standing up, so the lightning would be attracted to the metal pole rather than hitting a building. And the lightning rod would have a path all the way into the ground so that the lightning is being channeled into the ground and not hitting different buildings. Okay, we're going to read our first handout titled Scientists Study Natural Hazards, on how scientists learn more about hurricanes, wildfires, earthquakes, and floods. And we're going to answer these questions when we're done reading. Why do scientists need to know about wildfires to solve problems and help people? How can studying the location of earthquakes help communities? And how might knowing which materials stand up to the strongest winds help engineers? So these are our 3 questions. Let's go ahead and jump into our reading. Scientists study natural hazards. Scientists help communities. How can scientists solve problems and help people? One way is by studying natural hazards. Studying hurricanes helps them learn how strong buildings should be to keep people safe in high winds. There are many ways to study natural hazards. In wildfire labs, scientists study how fires grow and move. They might design new tools that put out fires faster and easier. Studying earthquakes helps us find out where to build the strongest buildings or bridges. Scientists can make stronger, more flexible materials. Engineers use the materials to design and build structures that will stay in place better as the ground shakes. Floods and hurricanes are also important natural hazards to study. How can a strong high wall keep water from reaching a community? How fast must winds be going to damage different materials? The work of scientists studying natural hazards, combined with engineers who design the building structures, help keep us safe. Now that we've read through our questions, you'll be able to answer the questions here. Or now that we've read through our handout, you can answer the questions here. Why do scientists need to know about wildfires to solve problems and help people? That answer is going to be found here in our first paragraph. How could studying the location of earthquakes help communities? That's going to be found right here in our second paragraph. And how might knowing which materials stand up to the strongest winds help engineers? That will be found in our second and third paragraphs. Once you've completed those, we're going to explore the digital interactive that's titled Building Structures on how buildings are designed in areas that are at high risk for earthquakes. Answer the questions after you've finished. So let's read through the questions first. What is the purpose of shock absorbers? How is the steel inside the building constructed differently than in other buildings? Let's go ahead and explore that together.
Click on the red dots to read about how engineers design safe buildings in areas where earthquakes are common. Building structures. Steel supports. The steel inside the building is built at specific angles. The angles are tested and made to support the greatest amount of movement in case of an earthquake. Windows. The glass in buildings where earthquakes are common is different from other glass. It is made so that it doesn't shatter with the movement of the building. Earthquake wallpaper. There is even wallpaper that has been developed to help reduce the impact that an earthquake will have on a building. The wallpaper is made of a glass fiber fabric. Shock absorbers. Shock absorbers are used at the base of the building. The absorbers are made with parts that are able to move a small amount but hold the building stable above.
All right, let's take a look at our questions one more time. What is the purpose of shock absorbers? So over here, you can go back and reread this section on shock absorbers, or you can pause the video, go through it one more time, and then fill out your answer. How is the steel inside the building constructed differently than in other buildings? That's going to be our first pin that we went through with the steel supports. You can pause the video here so that you can read through it and complete your answer. Once completed with those, we're going to watch a video titled Humans and Natural Hazards on the effects of floods, tornadoes, earthquakes, hurricanes, and wildfires, and how those can be reduced. We're going to answer the questions. How do scientists help us prepare for earthquakes? And how can the effects of all types of natural hazards be reduced? So we have two questions that we're going to focus on. Let's go ahead and watch that video together.
Floods, wildfires, tornadoes, and earthquakes. These are all types of natural disasters. And while not all natural disasters can be prevented from happening, the effects of a disaster can be reduced with proper planning and early warning. Floods are the most common natural disaster. Heavy rains and poor ground conditions can lead to flash flooding around rivers and streams. One way to reduce the impacts of flooding is to build flood walls made to stop high water before it causes damage. Tornadoes, on the other hand, cannot be stopped. But with the help of meteorologists, severe weather patterns can be spotted and people can be warned. Early warning sirens and TV and radio reports can help people seek shelter quickly reducing the risk of people getting seriously injured during a tornado. Additional safety drills help people learn the proper places to seek shelter and protect their heads during a tornado. Earthquakes can be very dangerous and scary. Some special scientists monitor the Earth's underground movement. Based on what they observe happening, they can quickly inform the public of the possibility of destructive earthquakes. People who live in areas where earthquakes occur most often know things to do during an earthquake that help protect them. They have designated places to go or to stand in a home, school, or building to help them stay safe. Wildfires are another one of Earth's natural disasters. These wildfires happen mostly in dry areas when water is low and the heat is high. Fires start and spread quickly over many miles, burning up dry grass, trees, and shrubs, as well as any homes in the area. People in these areas watch TV, listen to radio reports, or check news on the computer for approaching wildfires. These types of fires can grow very large and dangerous and cause a lot of damage. It is important that people hear quickly so they can evacuate the area if needed. No matter what area you live in, there are some things you can do to help protect yourself if a natural disaster happens where you live. Having an emergency kit prepared in your home is important, since natural disasters usually occur quickly and without warning. A well-stocked kit should include a complete first aid kit, a few days' supply of drinking water and canned goods, and other necessities such as batteries, matches, and flashlights. Natural disasters can cause a lot of damage, but with the help of scientists and new technologies, we are more prepared than ever before.
All right, now that we've gone through our video, how do scientists help us prepare for earthquakes? How can the effects of all types of hazards be reduced? Go ahead and pause the video so you can answer your questions, or rewind the video so you can re-watch this video on humans and natural hazards to find your responses. Okay, we're going to skip over this particular activity and jump ahead to page 261. We're going to read about preparedness. So how can you be prepared for a natural hazard? We're going to read through our handout, Be Prepared, and answer question number 9. How can you be prepared for that natural hazard that is most likely to affect your area? And you don't need to do the I can statement on this page. Let's go ahead and read through our next handout, Be Prepared. Know what to do. What does it mean to prepare for disaster? To prepare means to find out information and be ready. Communities help inform and prepare the people living in them for natural disasters. First, they think about what types of natural disasters typically happen where they live. If there are tornadoes in the community, they help people prepare for tornadoes. Television stations are prepared to alert people if a natural disaster is coming. On news broadcasts, the announcers will explain what is expected. There are also alerts that are sent to the viewers as storms are happening. When people have information, they might feel safer. Often, people with mobile phones can receive alerts about weather or other disasters as well. This will give them time to get ready. If a snowstorm is coming, families might get extra food so they don't have to travel during the storm. Many people have a radio with batteries. That way, if a thunderstorm knocks out the electricity, they can still listen for information. Schools are prepared as well. Many classrooms have an exit map posted in their classroom. Students and teachers practice how to exit the building safely in case there is a fire. When a large storm is expected, a hurricane, for example, communities often know several days ahead of time. They might suggest boarding up the house or making sandbags to protect their house and from the flooding that might happen. By being prepared, people can protect their things and their family. So we're going to go ahead and answer our question over here on how can you be prepared for a natural hazard that's most likely to affect your area. Go ahead and use complete sentences and lots of detail in your response. Next, we're going to explore the digital interactive lightning rod on how lightning rods prevent damage caused by lightning. We're going to answer the question, how do lightning rods work? Use the interactive and additional print and digital resources to research the topic. Take notes in the space below. So any information you can find in your handout, as well as any information you may look up online, you can list here. For number 2, make an argument. How well do lightning rods work to prevent storm damage? After you've completed your research, write a report on a separate sheet of paper in which you make a claim, support by evidence, arguing how well lightning rods work to reduce the impact of storms, and then summarize the argument you will make below. So instead of doing the full research paper, do some research on it and just give me a small summary right here on this page. Let's go ahead and take a look at that digital interactive together.
Look at the image and read about the lightning rod. This picture shows a lightning rod mounted on top of a skyscraper. A lightning rod is designed by engineers to help keep people safe. They are connected to earth or grounded. This means that if the rod is struck by lightning, the electricity will pass through the rod and go to the ground rather than damaging the structure.
Okay, so you can see this lightning rod is up on top of a building. It's on top of a skyscraper, which means it's a really, really tall building. Now, this lightning rod, when lightning hits it, it will redirect the lightning down into the ground so that it's not damaging the actual building or knocking out any of the electricity in the building. It's also not harming anybody. So go ahead and complete your 2 questions over here. Yes, you're going to have to do some additional research, either do it from books that we have in the classroom, from our library, or you can do this online. All right, and the last thing we're going to do is we are going to jump over to page 265 and begin on question number 4. How can people reduce the impact of hurricanes? So think about the reading and the handouts that we've gone through. Besides constructing a building that can withstand a hurricane, how can people reduce the impact of weather-related hazards? So again, go back to the handouts that we read, go through the information and summarize those right here. And for the last bit of our lesson, think about the video of the storm surge that we watched at the beginning of the lesson. How can humans reduce the impact of a storm surge? So I'm going to go ahead and play that video for you guys one more time so that you're able to answer your question. And that will wrap up our lesson. All right, now that we've done that, go ahead and answer the questions over here on page 266. Think about the video. How can humans reduce the impact of a storm surge? Once you've done that, you'll be done with our lesson for this last lesson 3. If you have any questions, let me know. Otherwise, have a wonderful day. Prepare for your quiz and your test. You guys are going to do great. Take care. Bye-bye.